We're continuing two-column proofs. Our first statement says segment LM is congruent to segment NO. So all of these two-column proofs are completely unfilled, and these last two don't have how many numbers we have. So as you've hopefully noticed that every statement has its reason and they are numbered. So 1, 2, 3, 4 statements, 1, 2, 3, 4 reasons. So it tells you how many statements and reasons you should have. So the first one we're going to put is segment LM is congruent to segment NO because it's given. LM has a tick mark, NO has a tick mark. This is congruent, we can put a check mark. The second statement is that triangle LMO and triangle NOM are right triangles, and that's because it's given. That because they're right triangles, when we look back at how to prove triangles congruent, we can look at side, 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 angle, side, angle, side, angle, 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 side, and HL. Right triangles go towards HL, so let's see if we can prove this using HL. So we already have that they're right triangles, and we already have the leg of the right triangle. We need the hypotenuse. The hypotenuse would be MO, and this one, the hypotenuse would be MO. They're the same sides, so that will probably be HL, so this is good. Right triangles. That means we can go ahead and say, yes, right triangles we can finish with that one. So now we just have to prove that segment OM and MO are congruent. So these would be congruent because of the reflexive property, because they are flush to each other. So we just got to name them correctly. So if we name it from segment MO, it's congruent to segment. So we started with M. So if we start with M, if I put a dot there, or just put a dot, this is between the 1 tick mark and the 2 tick marks. Do you see that? 1 tick mark, go up, down to 2 tick marks. So that's at the M. I started with the M. So if I start with the M here on this triangle, this is between 2 tick marks and no tick marks, which is not good. So if I go down to the O, you can see that it's between the 1 tick mark and then the 2 tick mark. So I actually have to start with the O on the second set. So segment OM, because of the reflexive property. Now we have a right triangle and hypotenuse and a leg. So these triangles are congruent, so we say triangle from our proof. Triangle LMO is congruent to triangle NOM because of HL. It's the first time we've had HL, I believe. No, we had it earlier too. Number 14. Segment AB is congruent to segment DC because it's given. So AB has a tick mark, DC has a tick mark, check. Segment AB is parallel to segment DC because it's given. I can't put a check mark on that because it doesn't say congruent. Then segment BC is congruent to segment CE because it's given. We have BC has tick marks, CE has tick marks, so we can put a check. So we have to go back to our given, and we have to use the word. So it says parallel. Parallel means alternate interior angles, which is the Z with the parallel lines. Or we have corresponding angles. So again, angles, which comes from the F, the corners. So we want to look at the actual lines that are parallel to each other. So if we look at the lines that are parallel to each other, these are the lines that are parallel. So we want to try and make either a Z or an F. So we can, if you look here, we can make a Z right here. we have the corner of A here, but then this corner is not even inside the triangle, so we don't want that one. We don't want the Z. So can we make an F, even if it's sideways? We can actually connect these, and that forms the F. So we can. We actually want to use this one. Now it gives us angles, so we're going to use the F, the corresponding angles. Therefore, angles are congruent. So the angles are the corners of the F. So this angle has just one angle here, so we can say angle B. Angle B is congruent to angle. Now this one we cannot say C because there's multiple things at C. See how there's multiple lines coming into C? We have to name this correctly. We have to go from D to C to E. Angle DCE. And the reason why it was the F part, it was the corresponding angles. Now we can put a check mark because we have congruency. Now we have all three. So we have a side, not congruent. We have a side here. We have an angle. Again, not the order, just the letters we want to use. So 2 S's and 1 A. We want to try and see side, angle, side. Does this arc touch the blue and the pencil? It does. This arc touches the blue and the pencil as well. So that is side, angle, side. So our two triangles, so triangle ABC is congruent to triangle DCE by side, angle, side. Next, we have segment PR is parallel to segment QS because it's given. And again, we don't have congruency, but they are marked, but we can't check it off yet. Statement 2 is angle QPS is congruent to angle RSP because it's given. So QPS, we got to mark this. So Q to P to S. So P is the vertex, that's one we want. This is the arc. And RSP. So S is where we want one arc. It's marked now, so we can put a check mark. We only have one check mark. So we go back to the parallel part. Parallel. And again, coming back up here, parallel looks for the Z or the F. Alternate interior angles or corresponding. So I'm going to, in blue, do my parallel parts. Not congruency, but parallel. And then can I make a Z or an F? And we can actually make a Z going this way. So we want the corners of the Z. See how the red is not touching the blue? So that's not the corner of the Z. This is the corner of the Z. We want to mark the corners of the Z. That angle and this angle, because those are the two corners. These sides are not parallel, so we can't actually highlight them in blue. So we can say that angle, we can't say P, we have to say angle RPS. Angle RPS is congruent to angle. We started with R, which has no mark on it. So if you look at Q, it has no mark on it. So we want to start with Q. We want to go to the green part, so that's S, and then P. And this was, because it was the Z, it was the alternate interior angles. So we put alternate interior angles. Now we can put a check mark on our given. We still only have 2 check marks, so we need to find something else. You can see that those 2 triangles are actually flush against each other where we put that Z, where we put that line. When they're flush against each other, that means that they should be congruent. These 2 lines should be congruent because of the reflexive property. So name this side is PS, segment PS is congruent. Now from one triangle onto the next, so using one triangle, before I went from P to S, I went from red to green. If I do this one, I have to go from red to green, but this time it's from S to P, so it's congruent to SP because of the reflexive property. Sorry, reflexive property. Segment PS is congruent to segment SP because of reflexive property. Now we have our last statement, so we can go and find what we need. Not congruent. This is congruent, so this is an angle. This is congruent, that's an angle. That's congruent, this is a segment, so it's an S. So we have two A's and an S. No, no, two A's and an S, two A's and an S. So it's either one of these. We got to figure out which one. So is this side, is the pencil touching both the red and the green? The pencil is touching the red here, and it touches the green here. The pencil touches this red and then this green. So it does touch both of them. It touches both the A's. So it's going to be ASA. So the triangle PQS is congruent to triangle SRP, because that's from our proof, because of angle, side, angle. Next, we have given that LP, segment LP, bisects segment MO, because it's given. Not congruent, so I can't put a check mark. And segment LO is parallel to segment MP. And it's given, so I still can't put a check mark, but I do have the arrows for parallel. So I have to use all of this to come up with congruency. So we have the word bisect, so we need to underline the word bisect and circle the next part. That's MO. So I'm going to highlight MO because that's the line that something's happening to. So MO, so bisect MO. Bisect means to cut in half, so I can actually cut this line into two different little parts. So I can have a congruent and a congruent. So now we can say that segment ON is congruent to segment MN because of the definition of bisect. Okay. Now we have congruency, so we have a check mark on that one. Then we have to use this next one, parallel. So going back to parallel, we're looking for the Z or the F. So I'm going to mark this in blue because these are my parallel. I want a Z or an F. And actually, you can make two Z's. You can make a Z this way. So let's focus on this one first. You can make a Z this way. And the corners of that Z, are congruent. So that L and that P are actually congruent. So angle L, and because there's only one, two lines going to L, we can just use one letter. Angle L is congruent to angle P. We can do the same thing for the same reason. Only two lines going to P. This is alternate interior angles. But we also had the other Z, because that highlighter, that was another part of the Z. We can use that one too. And the corner of this Z. So these corners are also congruent. So we can say angle O is congruent to angle M because of alternate interior angles. Now you could actually prove that these two angles are congruent as well by vertical angles. So it doesn't matter which one you do, you just have to be careful on naming your angles. And then if you prove the vertical angles, your final statement will actually be different too. So right now, I have 1, 2, 3 congruencies, so that means I can actually check off my parallel. I have all 3 congruencies. I have a side, a segment, so that's an S, an angle, and another angle. So I have 2 A's and an S. 2 A's and an S, so it's one of these two. So my side that is marked congruent, that's the yellow. Is my yellow touching both of my greens or just one of my greens? It's only touching one of them on this triangle. On this triangle, this yellow is also only touching one of the greens. I had to do the yellow because that's the tick mark. The tick mark is what I'm focusing on, which is highlighted in yellow. The blue was the parallel. So the tick mark was in yellow. That's only touching one of the greens. So it's only touching one of the A's. That's angle, angle side. So triangle LNO is congruent to triangle PNM by angle, angle side. These last two don't have numbers on them, so we have to figure out how many statements we need. We still go with statement 1. It's still our given. So it says segment AE bisects segment BD. We put 1 because it's given. Can't mark that because it's not congruent yet. So statement 2 says that AB, segment AB, is parallel to segment DE because it's given. And we also can't check that off. Now, these are actually very similar to the last problem we did. So I'm actually going to prove it slightly different so you can see the differences between them. So the first thing we have, again, is that bisect. We do need to underline that word bisect and circle BD because BD is what we're focusing on. So let's look at BD. Look at BD. BD is being bisected, so BD can be cut in half. So we can put a tick mark on those two parts. So statement 3 will be that segment BC is congruent to segment DC. And reason 3 will be the definition of bisect. Now I can put a check mark on that because I have a congruency. Statement 4 will need to come from the parallel. So again, parallel, we're going to use alternate interior or corresponding. So the Z or the F. So if I see the parallel, these are the parallel, we can create a Z from A to E. We can create a Z from A to E. So the corners of those are congruent. So we can say statement 4 is that angle A is congruent to angle E because of alternate interior angles. Now, I actually want to prove, I could still prove that these two corners are also congruent because of alternate interior angles, but I want to show you another way of looking at it. You can also prove that we have those vertical angles. So I'm going to say that's it for my parallel. And I'm going to go to my next one and say statement 5. I have vertical angles here, so I can actually say these two angles are congruent. So I would say that angle ACB is congruent to angle. Since it started with A, the one arc, this also has one arc. So E, I have to start with E. ECD. And the reason why is because of vertical angles. So now I look to see how many congruencies I have. No, 1, 2, and 3. So I have a side, I have an angle, and I have another angle. So again, 2 angles and 1 side. So my tick mark is my side. That's what I got to determine. Is it touching one or both? So the yellow highlight. Is the yellow highlight touching both of my green arcs or just one set? It's only touching one set. Same thing with this yellow highlight. It's only touching one set. So it's still all angle, angle, side because this side only touches one of the angles. So we would say for our final statement, so statement 6 this time, is that triangle ABC is congruent to triangle EDC by angle, angle, side. You could have also have, instead of proven A and E, you could have proven that angle B and D were congruent, and then you would have had angle, side, angle. That's just another way of looking at it. This last example, statement 1 is Q is the midpoint, I'm just going to put MP, of segment PR because it's given. Now, normally I would actually write this out all the way because I would write it exactly as it says, but having little room, but I would write it out all the way. So I can't mark that yet. So I go to statement 2, is segment PS is congruent to segment QT because it is given. Make sure you put your numbers. So I have PS has a tick mark and QT has a tick mark, so that is marked. And then we have statement 3 is that QS, segment QS, is congruent to segment RT because it is given to us. So QS has 2 tick marks and RT also has 2 tick marks, so I can put a check mark. So I haven't used all of my givens yet, so I go back to my given and I see a word, so I underline the word, then I circle the next part, and I focus specifically on that second part that's circled. So that's PR, so I highlight segment PR, and I focus on that midpoint. Midpoint means it's in the middle of that segment. That means that I should be able to cut it in half. So I can actually cut these parts right here are actually in half, so I can put 3 tick marks on there. So now I can say statement 4 that segment PQ is congruent to segment not. Okay, so if we look at this, you got to be careful. P is between 1 tick mark and 3 tick marks. If I were to outline it, I would touch the 1 tick and then the 3 ticks. If I need to do 1 tick to 3 ticks on this triangle, I would go from Q to R. It's congruent to segment QR. And that's because of the definition of midpoint. Definition of midpoint. Now I can put a check mark up here because I have congruency because of midpoint. Used all my givens. Got 3 check marks, so I have a segment here, so that's an S, a segment, so that's an S, a segment, so that's an S. So 3 sides. 1, 1, 2, 2, 3, 3. So we have side, side, side. So statement 5 is triangle PQS is congruent to triangle QRT because of side, side, side.